Welcome to Hunter Golf Rotor Production. I am your host, Aaron Gagnon, Associate Product Manager for Golf. In this video, we're going to go over the production for our TTS 800 series rotor. So full-scale production from molding, subassembly, full assembly, and quality tests all on the way with production for our industry-leading golf rotor. And let's begin. The first stage that we're performing here is sonic welding a diaphragm for our inlet valve. So there's a horn there, that metal component that presses into there and will vibrate, melt the rubber plastic to seal the diaphragm to its additional component. From here, more welding is done for welding the rest of the inlet valve. Next step, we add the filter with our leading industry filter century technology into our inlet valve, which scrubs the filter in operation. Next step for production for our TTS 800 is going to be for our riser. What this technician is doing here is she's beginning the stages for building our gearbox. So our gearbox is very special. We have the most torque generated from our gearbox out of any rotor in the industry, that is residential, commercial, and golf. The most torque. What that means, though, is that when there's gunk and junk in the water supply, sand, grit, it can just blast right through that. And you can feel it when you rotate the turret. If you were to have one in your hand, you can kind of rotate it and feel all those gears that this technician's kind of assembling into the gearbox when you try to rotate it. It requires more force to rotate it, and that's that torque that's building up. So when in operation, it can just blast right through any of that kind of sediment that could be inside the water supply. But what we're doing here, it's nothing really complicated. We're just taking components and stacking them on top of each other. We're creating subassemblies. And so the gearbox would be like a subassembly form of completing the riser assembly for then the TTS 800. This technician here is putting in the turbine, which goes into the bottom of the gearbox. So the turbine is what spins and gives the rotor its rotation, essentially. What drives the nozzle housing or turret to rotate. The TTS 800 has a couple of different flavors for SKUs. We have TTS 800 880, 884, and 885. So 880 is a complete full circle, non-adjustable. 884 and 885 are adjustable. They go from 60 degrees to full 360, non-reversing. That's huge. That's a nice spec to have. Non-reversing, so it doesn't stop and rotate back. It just completely goes in one direction and continue to rotate. So that's good for stocking for distributors as well. When you need to keep rotors in inventory at a store, you can just do one SKU potentially, because the 885 can be turned into an opposing nozzle with a rooster tail in the back, as some may call it, in the store. So this technician's completing that gearbox. He's putting the top piece of the riser on there and rotating it just to make sure everything's spinning and everything's doing good there. More steps for completing the riser underway. So we have a stainless steel riser. That's what this technician's putting on. And with the arc adjustment collar there, the gray band. Gray band indicates it's adjustable. We like using colors for our products so you can identify key features of the product. So gray means adjustable, black means it's full 360, non-adjustable. We like stainless steel. I'll mention that also. It's good for top dressing so it doesn't scar the sides of the riser and potentially create leaks. Another cool part about our TTS 800 rotor is the yoke assembly we have for the turret. So this technician here is putting all the yokes in there, and we're tapping in threads for the short and mid-range nozzles. But what's special about this, like I was saying, you can make our 885 opposing nozzle, not just forward-facing with those short and mid-range nozzles. You can remove the yoke. It just clipped in, pressure fitted, clipped in, and spin it around 180 degrees And now it's opposing nozzle. So you don't have to unscrew the nozzles, essentially. You just remove this yoke that we're tapping those threads in, spin it around, and boom, you got a full 360 opposing nozzle rotor. Well, obviously, once you adjust the arc to full 360. So crucial step here, being able to tap those threads in and easily remove any short mid-range nozzle. Like, let's say you need to have a certain area get a little more water on that turf, and you can easily unthread that shorter mid-range nozzle, put in a different one. We have a wide range of short and mid-range and main nozzles for any applications out in the field, including low angle nozzles too. We like our main nozzle though. It's lower than most main nozzles from the industry, and that just helps with wind that could be in the environment or in the forecast for the day. So if you're going to be irrigating, ours will perform better just with that normal main nozzle. But if you do have extra wind, maybe you're in a high prone wind area, we do have the low angle ones, which will perform even better in that case. So we're just about wrapped up with the riser here. This technician's threading on that rubber cover on the top. We're putting in that additional filter on the bottom, putting in the stator as well. Our stator is adjustable. It's a manual operation. So you make sure if you change that main nozzle, you need to change that stator. Body being molded. You can only do one body at a time. It's a big mold with a big component here, that body for the TTS 800 series rotor. The technician will grab that once it's done though, and bring it over to our CNC milling section. So the inlet is milled out. That's just because of how the mold is designed. We can't get around that. But technician will grab that, bring it over to our milling machine, carve out the rest of that plastic so it can then go to a quality step so we can check mins and maxes for dimensions of where the riser will be going into. Every step we're going to have quality checks though, from getting the resin, that is the raw material, to making the components. So it could just be just a simple gear. And then obviously after CNC is being performed with that body then additionally. This step here is we're spin welding the inlet of the body. So different than sonic welding where we just kind of vibrate it and melt the plastic. This one's spin welding, so it's spinning the inlet, creating that friction, that heat to melt the plastic then into the body. We're just about wrapped up here now with completion of the body, and we can go on to then full assembly of the rotor. But one cool thing about our body though is our flange compartment. We've got the most space than any other top serviceable rotor. So much room to do activities, but everything accessible from the top. You can change the two-way modules address, change it from station 501 to 937 without blinking with our ICDHP. That is not available to any of our competitors. They don't have anything like that. But everything done from the top without having to shut off any water, that is with the exception of removing the inlet valve. This technician now is installing all the components though into the body. So she put in the inlet valve, we're putting in the riser and our snap ring now next. After that, she'll take our two-way module, which is pre-spliced with the solenoid. So it's all one piece, one component. And what's really cool about this methodology or this assembly of our two-way module and solenoid, they're still separate pieces. So if one of them is broken, you can cut, splice in, one of those components. Versus all of them being kind of one over-molded component. If one of those parts breaks, you got to replace the whole thing, and that costs a lot more money than essentially replacing one of the components. So more assembly going in. We have our pressure regulator, which she put in, bracket to house the solenoid. We have the selector switch on, off, auto. Yellow is for two-way module, gray is for electric valve and head, so just solenoid. And if it's a green one, that means it's a grounded solenoid. Like I said, we like our colors. We want you to be able to identify things easily from the top and have access to things from the top. Last thing on the list here is being able to test every rotor. So we test every single rotor on water electrically. So every rotor coming out of our factory is going to be water tested. If it's a 2-wire controller, we put it on a 2-wire, if it's a 2-wire rotor, we put the wires to the connectors there, like it's acting as if it's on a 2-wire path, and activate it then from the controller. And we do it at the minimum voltage required for it to operate. So we're trying to simulate like worst case scenarios for operation with our products. All of our golf rotors, not just the TTS 800, but our G800 and our G900 go through the same quality steps, similar to this, exactly like this. So we want to experience the product when it doesn't operate. So you don't have, mass amount of quantities of rotors that you've purchased that aren't working. We want to go through those quality steps to make sure we can see all of that happening inside, and you have a smooth installation and a very, very long irrigation system that you can be using for many years at your golf course. But that's it. Thank you for watching our TTS 800 series production rotor. Thank you so much. Have a great day.
To find out more, go to hunterirrigation.com/golf.